Hi everybody, this is Unit 6 Video 0, and the reason we're doing a Video 0 is because I wanted to give an opportunity for you to review the introduction to this chapter. This is a big part of the chapter as we're talking about the domain and range of the inverse trigonometric functions. So let's go ahead and get started. So we're going to start here with the sine function and talk about its inverse and why the domain and range are restricted when we are looking at the inverse and solving inverse functions. So if we look here at the sine on the left-hand side, this is graphed over more than one period, but my range of the original function goes from -1 to +1. And that then becomes my domain. So my x values are now -1 to +1. Whereas my domain, which was all real numbers, has been switched where this vertically is now on the inverse graph is all real numbers. So I'm going to go ahead and plot a couple points here for you. So I'm just transferring this pi over 2 and positive pi. And then on the bottom, I'm going to go -pi over 2 and to -pi. So the problem we have here on our inverse sine function graph, which is on the right-hand side of the screen, is that when we go ahead and use the vertical line test, it fails the vertical line test because these vertical lines are passing through the function more than once. And therefore, we're going to have to find a way to restrict the function or restrict the domain, the range, excuse me, so that we're not running into this problem of repeated values. So I'm going to choose a piece of the function. I'm going to choose from pi over 2. And I'm going to go all the way down to -pi over 2. And this is the portion of the function that we're going to use where if I were to go ahead and choose values beyond that, you would see I'm running into the problem of the repeated vertical line issue. So if I choose only between -pi over 2 and +pi over 2, if you follow my cursor, I will have absolutely no problem with my vertical line test. So that's where our function is going to be restricted to. So my inverse function, which is y equals sine inverse of x, or y equals arc sine of x, that is the same way to say the inverse sine function, is that my domain goes from -1 to +1, whereas my range, which we would believe to be the domain of the old one over here, but it can't be because of our vertical line. So we're going to go from -pi over 2 to +pi over 2. And that is our new range, the new output values. All right, here's our cosine function. So we're going to, as you can imagine, looking at the graph here on the right-hand side, is that we'd run into the same problem with that vertical line test. So once again, I'm going to transfer my new domain of -1 to +1 over to the graph, and then I'm going to go ahead and transfer a few of these other points. So we have 0, of course, and pi over 2, and then up here, this point here is pi. Keep an extra stuff. And then down here, I have -pi over 2, and this point here is -pi. So as you can see, we still have that issue of repeated values if I were to use my vertical line test. So let me grab my highlighter, and if I take a look at the values from 0 up to pi in the vertical direction, I will have absolutely no repeats. As soon as I choose values outside of that, you'll see that my vertical line test would fail. So my new domain, or my new range, is going to be from 0 to +pi. And it is shifted differently than the sine, just like cosine is shifted differently than sine. So these are my values for my cosine inverse of x, or another way to write it is the arc cosine of x. And here is our tangent function, and I've actually gone ahead and drawn the entire inverse tangent function here, not the entire thing because it does continue forever. But you'll notice once again we're going to have the fail of the vertical line test when I graph my vertical lines here. So we're going to have to find a way to restrict this. And the way we're going to restrict it is we're only going to look in between one set or one cycle. And I will have no failures if I'm just restricted to that area. So my domain, as I watch this go on forever in both directions, will be all real numbers. So my domain of my inverse function is all real numbers, or from negative infinity to positive infinity. And my range is going to have to be restricted vertically from negative pi over 2 to positive pi over 2. But I'm going to not write these as square brackets. I'm actually going to erase those. Because of the asymptotes, I'm going to have to use soft brackets because I'm not actually including those endpoints as part of the function. The asymptotes are translated into these soft brackets. And this is the tan inverse or the arctan of x. All right, now I did not do your reciprocal functions with you. We did those in class, and this should be enough information for you to pick up on everything. This is a chart that's copied almost the same way from page 246, so you can take a look at that if you don't want to copy the whole thing down now. But what the most important part is I'm going to interpret the range of each of these functions into what quadrants they're actually going to assist us with. So for the sine inverse or arcsine of x, I'm looking at the quadrants that are involving negative pi over 2 to positive pi over 2, which is quadrants 1 and quadrant 4. Our cosine inverse or our cosine is quadrants 1 and quadrant 2. For tangent, I'm including quadrants 1 and quadrant 4, but notice the soft brackets, and those mean that I'm not actually including the endpoints or the axes in those situations. My cosecant, which is the reciprocal of our sine inverse function, is quadrants 1 and quadrant 4. Quadrant 1 and quadrant 4. We'll just do that. And my secant, which is the reciprocal of my cosine, is quadrants 1 and quadrant 2. So those match up perfectly. My tangent, on the other hand, which if you remember from graphing the tangent and the cotangent graph, they shifted a little bit. So you'll notice that they do not actually share the same quadrants. Quadrant 1 and quadrant 2 are my cotangent. This is another way to look at the range values of our inverse trig functions. Remember, these are just the range values. This is not the actual graph. The actual graph that are the ones that I showed you on the previous, the first 3 slides. So this is my sine inverse. And my sine inverse has a range values that will encompass anything between negative pi over 2 and positive pi over 2. We are looking at this as being a negative pi over 2 and then the positive direction a positive pi over 2. Rather than thinking of this as 3 pi over 2, 270 degrees, we're going to interpret it as negative 90 degrees. For my cosine graph or cosine inverse graph, we're looking at everything from 0 to positive pi. For the tan inverse graph, we are going to include everything from negative pi over 2 to positive pi over 2 with the exception of the endpoints. So I'm representing those by open circles because we're not actually including those quadrantal angles. That's where my asymptotes of the tangent lie. If you remember, when we graphed this, we had negative pi over 2 and positive pi over 2, and on those values were where my asymptotes were. So that's where my range values in these open circles come in. And then here I'm going to do my reciprocal functions, which we didn't actually do on an individual slide. But these are going to match with the exception of where the asymptotes fell. And my asymptotes on my cosecant are actually falls on 0. So I'm going to include my endpoints, but I'm not going to include the value at 0. That's an open circle. So it does go from positive pi over 2 to negative pi over 2, and it skips 0. And that's why on the previous screen I had that union between the two marks. So it went from negative pi over 2 to 0, and then again from 0 to positive pi over 2. These soft brackets and the union say that this value is not included. Next, I have our arcsecant of x, or the secant inverse of x, and those are going to be very similar as to this one, where I'm going to include the endpoints, but I'm not including pi over 2. So this too will have this union kind of set up here for our range values. And lastly, we're going to have the cotangent inverse of x. And that graph is going to look, it's going to look similar to our cosine graph, except we're not going to include the endpoints in that one. And this is our cotangent. So again, this is not the graph of them, but this is where you will pull the values from. So anything along or in this part of the unit circle are valid values, excluding these open circle endpoints or anything in between here where we do not have values. So when you're choosing the correct answer, make sure that you're choosing something from the quadrants in which the function is allowed to produce values. Also, big thing here, if you notice between all 6 of these trig functions, not a single inverse trig function produces a value from the third quadrant. That's a big thing. So you're really left with all of these produce values from the first quadrant, and then half of them split and share a value from the second and from the fourth. But none of them are from the third. Please continue to refer to this video throughout the rest of the chapter and as you prepare for your exam.